Appreciate everyone sticking around this afternoon to hear my talk. I'm Paul Coggin from the U.S. Specifically, I live in Alabama, back in the States. I'm a network security architect where I focus on offense and defensive methods for network infrastructure. I focus on the layer 1 through 4 of the OSI model is where I try to stay in my work. What I'm going to go over first are some ideas on what to do with network infrastructure if you're working on a penetration test team, red team, and you find that you're getting access to network infrastructure. I'm going to throw some ideas at you of what you might be able to do with, say, those Cisco routers that you end up getting access to, and also go into some ideas on some things that are not being looked at the macro layer in the WAN, specifically BGP, and most specifically MPLS. A lot of people are talking about BGP hijacking these days, but nobody's talking about MPLS that is probably being hijacked as well, just like BGP, but people are not looking at it or talking about it. So how are we going to get that initial access into someone's targeted routers? One of the ways we may go and gain initial access is do something similar to what we have up on the screen, where we've got some recon, some intel that tells us what the network management system is for the customer's network. Maybe they're running HP OpenView, Cisco Works, SolarWinds, maybe some open source tools, as you see over in the bottom right-hand corner. And that system has got a trusted IP address. The routers have been locked down so that only the IP address of that trusted device in the right corner is able to go and do network management of the network on the right. But maybe through doing a really good job of recon and intel, we were able to come up with and build a custom SNMP dictionary of community strings, because they're still doing SNMP v1, v2, and combine that with some spoofing using that SNMP blow script that we have shown there that you can download. And maybe we combine that our dictionary with the spoofing attack, and we're able to brute force dictionary attack the SNMP community string and gain access to the routers and switches, because when that correct community string is guessed, it's going to download the router switch config to us, whatever we're targeting, and then we're going to be able to get all of their intel, their AAA, their radius server information, username, passwords to the routers, access control list. We're going to get all the good intel out of that network device. And this might be one method that would get you that initial access to the routers. Typically what's going to happen is you're going to end up getting access through some other means. Maybe you're doing some web exploits, and you're going to get onto a system that's going to have router configs, and you're going to be able to go and get username, passwords. But what I see is during pen test engagements, the pen testers are leaving the network infrastructure as they're not digging into it. They just document that they found they got access to routers and switches, and they leave it at that. So I'm going to give you some ideas of what you might be able to do to escalate your privilege on the network once you get access to the routers and switches. One thing that you might be able to do is in the Cisco world, there's a concept called route maps or policy routing, where we can use access control lists to define the traffic that is of interest to us. Think of access control lists, maybe if you're not a router person, as a firewall rule set. So we go and create an access control list that's going to define the traffic that is of interest to us, source, destination, IP addresses, ports, services, and then we can combine that with a route map. And that route map, we can do policy routing that even though the routing table statically or through dynamic routes tells us to send traffic, say, to a specific destination east in the network, we can use policy routing to override the routing table to describe, based on the description we've given of traffic of interest with access control list, to maybe send the traffic north or west or south into the network and override that routing table specifically for the traffic that is of interest to us. And what that could end up happening is, if, like what I have been shown in the drawing here, in the center of the drawing, maybe we go and get access to their core switch. Maybe we can override the routing table and do a layer 3 man-in-the-middle attack. Everyone's familiar with doing the layer 2 man-in-the-middle attacks. Well, what about doing an inter-VLAN? Not the old school intra-VLAN with like ARP poisoning, some of the other layer 2 attacks, but what about doing it layer 3? We could do that with a route map. Or possibly go and force traffic that is of interest to go out of a back door, maybe out a 3G, 4G connection, and send the traffic that is of interest out a specific back door, so that we avoid the perimeter security, because most of the network monitoring I see out deployed is at the perimeter. Well, maybe we can bypass the perimeter security and go out reroute out a back door through the 4G modem we have out there. Now, more advanced attack might be someone up in the service provider realm overriding your traffic and trying to forward traffic out a different path using this method. Another technique that you might not be aware of if you're not an old school router guy it, and a pen tester is there's a capability we used to use in the old days of using GRE tunneling to tunnel non-IP routed protocols like DegNet, XNS, AppleTalk, the Novell stuff. You can still use the GRE today for tunneling IP across the internet, but I cut my teeth doing anything but IP over GRE across wide area networks. And what we can do is we can build these GRE tunnels where we can tunnel traffic between a router that we've hacked into a router that we own, that we have under our control somewhere out on the internet, and build a tunnel. And using that technique of route maps that we just discussed, we could use that route map technique to force traffic to override the routing table to go over that tunnel so that we could sniff traffic and do packet analysis remotely across the wide area network. So that's a technique you might be able to use. Similarly, if you end up finding you're working on a pen test, you're getting access to routers, you're getting into switches. Could be another technique a lot of the guys are not familiar with yet. They know about doing span port, local port mirroring on a switch, or maybe doing RSPAN where you can mirror switch to do packet capture. Well, there's a technique that we could use called ERSPAN where we could specify the IP address that is of interest to us and mirror traffic out across the network to an IP address of a network device that is of interest to us so that we can mirror traffic across the wide area network. That's a technique and method we might use during a pen test engagement to escalate privilege across the network. Another technique that I ran across that wasn't documented, where you could go, if you get yourself into a router that's still, it's got the feature set, maybe it's got a really robust Cisco router feature set that supports the DLSW commands, where DLSW, if you're not familiar with it, is a method for tunneling SNA and SDLC protocols, some old IBM protocols, across an IP backbone. So we can, if we have the features there on the routers that we've compromised, we might be able to turn on DLSW and bridge IPv6 across the IP backbone, where they might not be running IPv6. Well, we can just go and tunnel the IPv6 across the IPv4 network using DLSW possibly as a way to launch IPv6 attacks across the wide area network. Another technique, if you don't work in the service provider space, there's a technique that you could use on the routers if you find that you've gained access called L2TPv3. With L2TPv3, what we can do is we can create a logical pseudo wire where you can think of being able to logically drag and drop a VLAN, a wire, across a wide area network, across the whole internet, and connect, say, your VLAN 10 to VLAN 10 from, say, VLAN 10 in South America to VLAN 10 somewhere here in Europe. And you can, with L2TPv3, you can drag and drop a pseudo wire across the internet and bridge that traffic all the way across the network, and you basically connected your two layer 2 network domains. So all those old school layer 2 attacks you could possibly use across the wide area network using L2TPv3. This is another technique that you might use. You know, if you get access to the routers, they're never going to see this stuff coming. Once you get access, this is some techniques that you might be able to use, but you're going to have a feature set that's going to support it. Another technique to be aware of, if you're out popping shells on routers, getting enable access on some Cisco boxes, if they've got the feature set on the routers, and if they don't, if it's inside your rules of engagement, you might go and upgrade their router code for them, because if you've gotten access, they're probably not going to know you've gotten access. And if it's in your rules of engagement and they got the memory to support it, why not go and upgrade their code for them so that you can get the features that you need and you want for the project? So maybe one of the features that you might add to the network, if it doesn't already exist, is lawful intercept, where lawful intercept is the capability that law enforcement typically uses to do an IP-based wiretap, where you got two entities that are talking that is of interest, say, to law enforcement. Well, they can go in and define the traffic that is of interest, and the service provider has got to be able to support, in the US we call it a warrant, and every day that say a service provider cannot provide this capability where two entities are talking and the law enforcement wants a copy of that traffic, where they get a copy of everything that's being sent, it's a $10,000 a day fine. So they have this capability in the cloud. Well, what if, since this is in the network infrastructure, if we're out there hacking network infrastructure, why can't we take advantage of this? If we go and get access to some network infrastructure that has the lawful intercept capability, or if it's in our rules of engagement that we could turn on the features, add the features, why could we not go use that? That's what hacking is, right? Go and do the unexpected. So we could possibly go in and hack the router, and all the traffic that is of interest to us, we could define with an access control list, and maybe get a copy of it, and maybe we could go and get the credentials that we need to escalate our access on the network infrastructure. Just something to consider. And of course, the box of, our system is going to be capturing all that traffic where we can sniff it, see what interesting traffic we're getting. Here's a technique we ran across. What's happening here is you have a service provider. They've gotten into the cable TV business, IPTV. They're streaming multicast traffic from a third-party service provider that has got a head-in where they sell IPTV services across their fiber network. They may have a big, large WAN that they provide centralized IPTV streaming services to numerous smaller service providers. And so they're going to bring that connection in. And what you're going to have is it's going to come into that network over on the right, what we call a head-in. In the telco world, they call it a central office. In enterprise, we call it a data center. In the cable TV world, they call it a head-in. So you're going to stream traffic from that managed service provider up in the upper left-hand corner over to that cable TV head-in on the right. And typically that cable TV head-in is going to be full of a bunch of Solaris boxes. And you guys that have been pen testing for a long time, if you're an old school Solaris guy like I am, there's some rich old school vulnerabilities in them Solaris boxes. You get in these networks, they don't get patched, they don't get upgraded. You get this stuff working, nobody touches anything till the network gets totally forklift upgraded or somebody dies or retires. You don't touch this stuff because it's working and it's making money. You don't screw up the TV. When the guys are sitting at home clicking channels, it better be working. So this stuff gets deployed. And so if you go in and you start hacking this stuff, if it's on an engagement, it's going to be a really rich environment for popping shells on Solaris boxes. But the problem we have is with multicast routing, make the stream, these servers that are over in the right-hand corner in the cable TV head-in, for them to forward the multicast traffic, they have to have a route pointed back to the source network. So these devices on the right-hand side, most of those systems that are involved with the multicast IPTV are going to have their default routes in most cases pointed back toward that cable TV head-in. And so what happened in an engagement, we got access to the routers down there at the bottom, the center, that head-in router, and we knew that there was a rich target environment where we could not get a connectivity going. And what we've discovered is, obviously because of the way multicast routing works, the servers could not get a two-way connection because they did not have a route out to the internet. So what we discovered, a technique that you might use if you find yourself in a similar situation where you got on the router and you're looking at the ARP cache and you see the mappings are there and you know that you got host that you could pop, but you can't get that two-way connection. What we discovered is turn on NAT. Turn on NAT on that external interface, set up some static NAT translations, and the router will proxy that connection, and you can get a two-way connection, and you can start popping shells and start pivoting, depending on what your rules of engagement permit. This is everywhere. These type of protocol problems are. I was on a pen test engagement not too long ago, and I found like 6 to 8 protocol problems of a similar nature of this OSPF. It was first hop redundancy protocols like VRP, HSRP, numerous protocols where they're just multicast out on the wire. The pen test team was ready to call it, or they were done. Everything was done. Went into this network that had been totally tested. Just all I did is fired up Wireshark and found like 6 to 8 vulnerabilities just as fast as I could. Took longer to pull up Wireshark than it did to get 6 to 8 Cat 1 vulnerabilities. So what's going to happen here is you're going to pull up Wireshark in a lot of these networks, specifically in the enterprises. and you're going to see the OSPF, you're going to see EIGRP. You still can see some RIP out there. I do run into RIP occasionally still, RIP version 2 and NG for V6. And what's going to happen is most typically they're not going to be running any kind of authentication, though they could run a hash authentication between the routers. They're not going to be running they typically will not be doing that. If they're running authentication, it's going to be clear text authentication, so you don't have to worry about cracking the MD5 hash or anything like that, because it's typically, if they're doing it, it's going to be open. But most likely what you're going to see is no authentication at all. It's just going to be out in the open. And that traffic should not be dropped into the VLAN to begin with. The end users should not be seeing that OSPF traffic. It should be passive, so that the routers only advertise the networks, but for the VLANs, but the end users should not be able to see that traffic. So what you can do is, if it's inside your rules of engagement, you're out there doing a pen test, red team engagement, why not go, if they're advertising that OSPF, that EIGRP, the RIP out into that VLAN that you've gotten access to, why not take advantage of it and fire up your own router and join their routed network and start advertising routes? Wouldn't it be interesting if you're on an engagement, it's inside your rules of engagement, you fire up some kind of a router and you start advertising networks for, say, Interpol, MI5, MI6, NSA, CIA, Microsoft, Google, advertise those routes into their internal network, and then source your attacks, your pen test, whatever you're doing with your pen testing, source your traffic from IPs out of those blocks. If somebody gets smart and starts looking at their logs, they're going to see attacks from somewhere out in the world, and you're really on the inside. And you're going, it's going to be like Keystone Cops watching them go out and do whois and looking up these IP addresses for organizations that are out there somewhere in the world, but you're actually on the inside injecting the routes into their network. How I would probably do that is using something like Quagga on your Linux box, or using NRL Core. If you go out to the Naval Research Lab, they have a tool called Core that will emulate routers. It's a really nice network simulation environment. If you don't know about NRL Core, you need to go check that out. Maybe we go and fire up GSN3. We've got a copy of iOS or GNOS or something, and we fire up a router in GSN3 and join their network and start advertising routes. Now, BGP's been in the news a whole lot here lately. If you follow it, especially on Twitter and a lot of the threads I follow, there's been lots of attacks where IP addresses are being hijacked. If you don't follow it on Twitter, if you're on Twitter, you need to be following BGP Stream. And there's like daily updates, tweets coming out where IP networks are being hijacked and people are not looking for it. And this is happening like crazy. It's hard to keep this up to date because there's just more and more data coming up on networks that are being hijacked. And basically what happens with the BGP hijacking, if you're not familiar with it, BGP is the protocol that runs the global internet. If you're not running BGP, your upstream service providers are running BGP for you. If you're an enterprise, you're going to run BGP if you have multiple connections to the global internet and you have the ability to fail over between connections. You're not going to be running BGP if you got like redundant DSL cable connections. This is going to be big pipes through the internet. Typically an enterprise or service provider is going to be running BGP. And you're going to have an AS number that you're going to get, say, from Aaron here in Europe, Aaron in North America, Rop here in Europe. And they're going to give you an AS number, and you're going to have your IP space that you got from them, maybe IPv4 and IPv6. And there's an implicit trust relationship out there between these AS numbers, and there's nothing to stop someone from accidentally. It's always an accident. It's always an accident. If I did it, it would be an accident. That'd be my story, and I'm sticking to it. But somebody's going to accidentally start advertising your IP addresses as theirs, and what could happen is they're not going to get all of your traffic, but traffic that has got a more preferred metric to whatever network is hijacking your IP addresses is going to swing over toward them, and they're either going to drop your traffic in the bit bucket, or they could go and capture the traffic and forward it on, or maybe capture traffic and define traffic that is of interest, capture it, modify, and rebuild the checksum and refire it on to its end destination possibly. Depends on what their motive is. Now, this is happening like crazy. And like I said, you ought to be following BGP Stream on Twitter if you're not already to see how bad this problem is. Like it's I go like crazy. But here's my question. How many of you guys have run MPLS or have customers running MPLS? If you're running MPLS, are you monitoring your MPLS VPNs to see if there's new networks being injected into your private MPLS VPN? Are you running some kind of encrypted VPN across it? Just because VPN is used in the terminology in MPLS does not mean it's encrypted. Our terminology is being hijacked, and one of the key examples is VPN. VPN, virtual private network, does not imply encryption. As you see here in this diagram, a VLAN is a VPN. The frame relay, ATM PVCs, X.25 circuits. Those are all examples of VPNs. They're not encrypted. Why do we assume that an MPLS VPN is encrypted? Because they're not. We do not have encryption until we overlay encryption across that MPLS network. What I want you to get out of this piece of the talk is if BGP is being hijacked, if our IP networks on the public internet are being hijacked, why would a bad guy, why would a criminal nation state organization not be also hijacking the MPLS networks if they have this router access? I'll build the service provider networks for a living when I'm not out doing security work. I'll build service provider telco critical infrastructure networks, and we put in BFRs, big freaking routers, where your server guys are virtualizing your servers. Well, the router guys like me, we're virtualizing our routers with MPLS, and we've got we just put in one big router, big as a door, and fill up a rack, and it gets carved up. And we've got your internet, we got all the different customers' internet, all the different MPLS VPNs, IPTV, all the voice over IP services are all running across one big router, and it's all carved up virtually with MPLS in most cases. And so whoever is doing the BGP hijacking most likely has access to a lot of customers' MPLS networks. I'm just thinking the criminal mindset. If I ever go criminal, I'm going after all the money. I'm not going after a little bit. I'm going after it all. Uh, and so let's think about this. So here's what's going on with MPLS for you guys that are not familiar with it. I'll give you a real quick overview. MPLS works at layer 2.5 of the OSI model. It works, there's a shim between the data link and network layers. That's what I'm showing here. You're seeing this slide, a packet capture between the Ethernet header and the IP header. We have the MPLS labels, and these slides are going to be available for download, so you can look at this offline. But you'll see there's 3 different MPLS labels injected there for like the MPLS VPN, MPLS traffic engineering, etc., all there that you can look at. Now here's how the MPLS network is architected. In the core, the service provider has what they call P routers, and they're just speeds and feeds. These are the big routers that are just pushing major pipes. It's where your 40 gig and 100 gig traffic is being, where it's being put in first in the networks as they upgrade. And then you get out to the edge with the provider edge, and that's where they're aggregating all the customer traffic is on those PE routers. The PE routers is where the magic's happen with the BGP hijacking, and that's where your internet traffic's being aggregated. That's where your MPLS VPNs, your Metro Ethernet, all of those services, your voice over IP, your SIP services, all of that is coming in from those PE routers, provider edge. And then you get out there to the edge to the Cs, which is the customer edge routers, which is whatever type of routers, services that you have out at your customer side. And what happens is we go and carve these networks up with MPLS VPNs. It's going to carve up these networks so that we could have redundant IP addresses and things like that on the networks, because we don't see each other, because they're all in MPLS VPNs. We're like ships in the night. Well, here's an example of the config. This is how somebody could accidentally mess up your the router configs on a provider edge router and start injecting routes into your network, or possibly bleeding routes out of your network into somebody else's MPLS VPN. And basically what they do is they'll create a VERF, like you see up there at the top. They'll create a VERF for each customer VPN. They'll create a route descriptor to define that VPN, and then you go in and create a route target statement that's going to imply the policy for importing and exporting VPN routes. And that import export is where the magic happens of pulling routes in and out. And so if somebody accidentally fat fingers that route target statement, they could pull networks into your network or bleed traffic out of your network into somebody else's. This is how simple and easy it is. Now, this is what it's going to look like. You guys that have programmed routers, maybe you're an enterprise and you haven't dealt with the MPLS, you're probably familiar with doing show IP routes where you see your global routing table. When you're going to start turning on the MPLS, what's going to happen is you're going to do a show IP route, and you're going to have to specify VERF, and you're going to have to specify the customer VPN, the MPLS VPN that you're interested in, and then you will only see those routes. Because we're like ships in the night in the router now. We're showing 3 router tables. We're on the same pipe, we're on the same router, we're running across the same fiber, but we don't see each other. It's the whole ships in the night concept. And this is what it looks like from the provider edge to the provider edge with BGP community strings, because those provider edge routers, those PE routers, are going to run BGP between them across the core network, and they're going to advertise the MPLS circuits. And this is just a PCAP of that you can look at offline. So how does a service provider network get compromised? Let's assume that there's no insider threat, because that's the big argument, right? When you go out and do pen tests, there's no insider threat. Yeah, right. So maybe let's go from a standpoint that all the threats are outsiders. How is the threats going to get access to this network? Well, what I come in and I look at the trust relationships. I go and get all the intel I can about the organization, where they've leaked out lots of good information in their press releases, bragging about the infrastructure that they're running, LinkedIn, etc. And we're going to go in and we're going to analyze the trust relationships, the network management system, the business systems, the web apps, et cetera, that they're running, the different vendors that make up that system. Because one thing about vendors, they're consistent. And they're going to roll out everybody's network consistent. So when the field engineers go out and work on the network and they get called in on site to help you fix it, or you call in to the help desk for remote support, they know what they're dealing with. And so they would come up with template architectures, and we roll things out pretty consistent. And so if you can go and get that kind of intel, it's going to help you come up with a strategy. And what I like to do is develop attack trees. When I gather all this information, I go and develop attack trees. A tool that I recommend you look at using for developing your own attack trees that cranks it up a notch is a mind mapping tool called Xmind. Use Xmind to develop your own attack trees to document your strategy and flow through in how you may go after that organization's network. One of those vectors, if you do a good job, you're going to find a way in. So what we got here is a single service provider network architecture. This is a single service provider. They got their up there top. You got their internet connections out to the core global internet, and you drop into their core internet architecture, and then you drop down into their MPLS network. And down at the bottom, I show where they're aggregating different customer services. When I first created this talk and I had not presented it yet, I was at a B-Sides and was talking about that I was working on this presentation. A gentleman came up to me after the B-Sides conference. We were at the party after the conference. He said, people better listen to that MPLS conversation you're having, because I caught traffic from another country coming from my MPLS network, same architecture, single service provider, MPLS network, regional MPLS network, only one service provider involved. And he caught traffic coming from another country from his MPLS VPN back out his firewall. It wasn't the service provider that called him and told him that they'd been hacked. And as a result, he had traffic coming in into his private MPLS VPN. Wasn't the telco. He found it in his own firewall logs. And he traced it back to another country. And so this is a real deal story. So what could somebody do if they break into the network using maybe the methodology we just looked at on the attack tree, or if you got an insider threat, maybe they do some of those techniques that we just talked about, like the lawful intercept, maybe the L2TPv3, the ER span, or the GRE tunnel. Maybe they go and create a GRE tunnel to their router out somewhere on the internet and add that tunnel to the MPLS network and join your private MPLS wide area network. Maybe you end up with a whole new site on your network, and they're injecting routes into your private network for your institution. My question is, if someone joins your MPLS private network, can you detect it? Do you know it? If you're running MPLS VPNs now, do you know that? Do you have that visibility? Are you doing that level of monitoring? Most of the networks people I talk to, they have no clue. The only ones that are really protected are the ones that have an overlay encrypted VPN across it. So here's a Here's an attack vector where someone may go and get into a telco. Let me walk you through this. This is a real world story with all the details removed to keep me out from being sued and prosecuted. But this is real. I came across a network. Customer was moving from one telco to a second telco. The first telco, they had the customer had like 60 plus circuits with the first telco, and they were moving to the second telco. The contract had been in place for a very long time. The telco decided, hey, you know what? Since we're losing the contract, it's going to cost us more money than the equipment's worth to ship it back and do something with it. They just abandoned it in place. They abandoned all the equipment in place. My customer, through merger and acquisition, doubled in size very rapidly. And he's like, hey, Paul, I appreciate, you sold me all that 60 plus routers for the first project. Now we just doubled in size and we're going to need 60 to 80 more routers. But guess what? They abandoned all that equipment. We're going to use that equipment they got abandoned. Customers started doing password recoveries. And guess what was all in that information down there in the right-hand corner? Their username, passwords, all their routing information, their SNMP community strings, their access control list for their security policies. You name it, it was in there. The keys to the kingdom was laid out there. It was beautiful. It put a tear in the router guy's eye. It was the tightest router config. It was a beautiful router config. It was nearly perfect, except for they left the routers out there for somebody to do password recovery. And so what could you do with that? I mean, this is simple. This is just one example I saw. And you hear the cliche about everybody go out on eBay and buy equipment and you can find similar information. Well, this happened real world for me. And what's in that information is all the keys you need, the attributes for up there at the top of the network. If you could go and get on LinkedIn, go and find out who the network guys are and do a social engineering attack, maybe do some phishing attacks, and get access to the right network guy's home computer or his laptop, you could go turn around and VPN, piggyback on that gentleman or lady, whoever it is, get into that network, and you're going to know exactly what systems to go target now because you've got all their information out of their router configs. You know what IP addresses to hit. You don't have to go do any scanning. You know how to go and do a surgical attack against their network infrastructure. And oh, by the way, you got the username passwords. And most likely, all things being consistent, you're going to end up being able to get into their optical infrastructure, go down to like layer 0, maybe their DWDM network where they're multiplexing optical wavelengths over their fiber network. Maybe you're able to go and escalate your privilege into their SONET, TDM, SDH network, all the way up into their router switch network. Maybe further up the stack into their servers via that information. The dominoes are going to fall. This is a way that the network could be taken over totally. So here's something to think about for the organizations that are running MPLS globally. Maybe you've got MPLS circuits going from South America to Europe or Europe to Asia, other parts of the world. When you're out there buying MPLS circuits, you might have one bill for all your circuits. You might have couple hundred MPLS circuits, and you got one throat to choke. You got one telco that provides your billing for you that you buy your MPLS circuits for. What I want you to get out of this is they don't own the telco services, the infrastructure for the whole world. They have peering agreements just like we do in the BGP internet world. They have it for the private networks as well. And they're going to have peering points, cross connects, where MPLS networks tie together. And as soon as you leave your service provider in your home country, you start going outside that country, you're getting probably on multiple different service providers' networks. You're inheriting a trust relationship with all the criminals and nation states in between point A and point B that your circuits are terminating with. And this is where I go and want to reinforce to you that most likely what's happening, because it's happening with BGP on the public internet, why would anyone that's doing this not do it to the MPLS circuits as well? Unless bad guys have changed. I mean, the criminals that I know, they're going after all the money. And if they have access to the BGP routers, they know BGP, they know MPLS as well. And they're probably taking advantage of this. So I'm not all bad news. Here's what we should be doing. On the BGP side, if you're not already monitoring your IP prefixes and being proactively alerted when there's an issue, we should be go out and check out something like BGP Mon You can BGP Mon, who got bought by OpenDNS, who got bought by Cisco recently. They offer a service where you can give them your IP prefixes, and they will proactively alert you whenever your IP addresses have been hijacked. You could go and check out BGP Stream on Twitter. They have a service where they're tweeting out IP networks as they get hijacked. Uh, I prefer the BGP Mon because it's all automated for me, and I know exactly what's happening with my IP addresses or my customers' IP addresses. Another thing I would look at is why not go ahead and look at your industry peers, maybe your suppliers, that whole trust relationship you have in the industry, whoever, maybe you're doing, whoever your contractors are that are providing services. Why not go and monitor people in your chain of trust, their IP prefixes to see if they're being hijacked? In your competitors. Why not go and monitor the IP prefixes of your competitors and see if they're being hijacked? It may give you an early warning that you're next. If they're interested in your competition, they're interested in your suppliers, maybe they're interested in you as well. Maybe they're going to pivot off of them, off the information they glean. You don't know if you're not monitoring. From the MPLS standpoint, if you're a service provider and you're going you might want to go look at doing MPLS across your core infrastructure. Most do not. I've never seen any of my service providers do IPsec encryption across their core networks. But as an enterprise, you should be overlaying encryption across your MPLS VPNs. If you're not, you very well could be find that you've got MPLS, your MPLS VPN has got routes being injected into it. And if that's the case, that you're not going to overlay an encrypted VPN across your MPLS VPN, then you really need to be looking at your router logs and monitoring for unrecognized routes being injected into your routing tables. The other thing I recommend is go to two-factor authentication. You don't want to be using static passwords, because if I find my way into wherever your server, wherever your router configs are archiving, if I get into those configs and you're using static username passwords, I'm going to eat that network alive. If I'm going to do it, somebody that's really sophisticated, they'll tell them what they're going to do with it. Because this is one of the areas that we're seeing is from the forensic incident response standpoint, everybody's beating up the Microsoft guy and everybody's joking on the Microsoft guy. But how many networks use the same username password scheme for their network infrastructure as they do on the Windows systems, but nobody's challenging the network guys. And when they go in and do forensic incident response, not going and doing a full incident response against the routers and switches to make sure they haven't been compromised as well. One of the things I'd also recommend is we talk a lot about application whitelisting. Why not go and implement network-based whitelisting? We should know we should build a traffic matrix of who's talking to who, where, when, and how much. And instead of waiting to get budget to roll out some application whitelisting tool and disrupting the end user base, why not go and go and do a traffic matrix using NetFlow and get a baseline of what's normal for our network, who should be talking to who, and then implement a policy in our access control list to lock down the trust relationships in our routing tables and our routers, so that only the networks that should be talking to each other can talk to each other. And anything that violates that, flag it. Maybe if we can't block it because we don't have the confidence that we don't want to possibly disrupt network traffic, why not go and put some logs in on it and just log anything that is curious, that is unexpected, if we don't want to go block it, and then go and investigate it and identify why are these networks talking to each other when they shouldn't be on the internal network, not just at the perimeter. So here's some references that you may want to check out. Like I said, these slides are going to be available, and here's a bunch of references, books, papers you can go back and look at if you want to dig into this further. One of the best sources out there, if you're the ERNW guys up in Germany, they're awesome. They're probably one of the top network security firms in the world, in my opinion, and they do a really deep dive in network infrastructure. So I'd recommend you go check out ERNW and a lot of the papers that they've published on MPLS and layer 2, layer 3 security, IPv6. I can't recommend that you go look at their papers strongly enough. And Yvonne, that's right there below the ERNW link there. Check out Yvonne's references. He's got a blog site He's also iOS Hints out on Twitter. Go check out his resources. He goes far beyond what I've gone in these slides between ERNW and Yvonne. It's a wealth of information, and also FX. If you don't know FX, you got to go dig into FX's information. Just a wealth of information out there. So that's all I had. You guys got any questions? Anybody got any questions? Well, cool. I appreciate everyone's time and sticking with me this afternoon and coming out and hearing my talk. Thank you. And I want to, before I quit, I'd really like to thank DefCamp for letting me come to Romania and introducing me to your country. I've had a wonderful time here in Romania, and I can't wait to go and see more of the country. Met a lot of great people.
Yeah. Thank you
It's
so
awesome.
much.
Thank
Thank you so much.